Welcome to page 6, part A. Today we will be given a graph and we have to write the equation for that graph. Our linear equations will either be proportional, and we'll write an equation that looks like this, or if they're non-proportional linear equations, we'll write an equation that looks something like this. mx plus or minus b equals y. If an equation starts at 0, 0 and it's straight, it will be a proportional equation. If our line is straight and it doesn't start at 0, 0, then it's a non-proportional equation. Let's take a look at the first graph that we've been given. You can see that our x-axis represents time in hours, and our y-axis represents distance in miles. If you look at the scale along the bottom, we see it goes up by 1 hour each and every time. If you look at the scale running up the side, each block is worth 10 units. And they've only labeled 20 miles, 40 miles, 60 miles, etc. So as we calculate the slope, the rise and the run, we have to be careful to read the scale on the y-axis and the x-axis properly. Well, let's take a look at problem number 1. Part A. It says find the rate of change, also known as the slope, find the y-intercept, and write an equation. Well, clearly, if we look at our y-axis, we see our intercept is right here at 0, 0. The line passes through the origin, so our y-intercept is 0. This is a proportional relationship, so when we write our equation, it's going to be k times x equals y. Our job is to calculate the slope or the rate of change, which is delta y over delta x, or rise over run. Let's take a look. Place your pencil point at 0, 0. In order to calculate the rate of change or the slope, we need to examine the change that occurs between this point and the next readable point, and then continue on and examine the change that occurs as we connect those points. Remember, we're looking for our rise over our run, which of course is delta y over delta x. So with your pencil point at 0, 0, rise up 60 miles and run sideways 1 hour. It appears as though our delta y over delta x is 60 miles per 1 hour. But do it again and confirm that. From 60, go 60 to 120, which represents 60 miles, that's the change, and run sideways 1 hour. We consistently rise up 60 miles and run 1 hour to the right. So our rise over our run is 60 miles per 1 hour. That's our unit rate. 60 divided by 1 is 60. So when we write our equation, we get 60 times x equals y. Now, let's take a look at problem number 2. Here we have to find the slope or the rate of change. That's our delta y over delta x. Please write that down. Also known as our rise over our run. Then we have to find the y-intercept. And finally, we need to write an equation. Well, let's take a look at what we've been given here. If you look at this particular graph, the title is Landscaper Charges. Across the bottom, our x-axis is the number of houses. And you can see that 2 blocks represent 1 house. 2, 3, 4. And up the side, charges in dollars along our y-axis. In this case, each block is worth 15, but they've only labeled 30, 60, 90, and 120. Our initial start value, our intercept on that y-axis, is 30. Please write that down. We know it's not a proportional relationship, so we are going to use the equation mx plus b equals y. And we already know our initial start value, b, is 30. Let's take a look at our slope. Place your pencil point here and darken a dot right at 30, at our intercept. And we're going to examine the rate of change by connecting a few of these points together, studying the rise and the run. So here we go. Placing your pencil point on 30, rise from 30 up to 60, which means an increase of $30. And as we run 2 blocks to the right, that represents 1 house. And if you do it again, going from 60 to 90, rise 30, run 1 house, which is of course 2 blocks, but it represents 1 house. And this is a consistent pattern. We are rising $30, that's the change in y, and then the run sideways is 1 house. 30 divided by 1 is 30. That's our slope. Your equation is 30 times x plus an initial start value of 30, that's our y-intercept, equals y. Now, take a look at our equation on the bottom. You're going to complete this one on your own. Pause the video, and when you're ready to check it, turn the video back on. You're going to find the slope, the y-intercept, and write the equation. Well, very quickly, across the bottom, x is time in hours, and 1 hour is 2 blocks wide. Now, going up the side is total distance in miles, and each block is worth 60. However, they've only labeled 120, 240, 360, and 480. We are looking at train 2 speed. We're going to start here, and let's connect up and check the rate of change on a few different points. First of all, it starts at 0, 0, so you know your intercept is 0, and that also means that the equation will look something like this. K times x equals y. It's proportional. Finish the rest of this on your own, pause the video, and turn the video back on when you're ready. You should have gotten a slope or rate of change of 120 miles per every 1 hour, and when you divide, you get 120. Your equation, 120 times x, x being every hour, 120 times x equals y, the total distance. This concludes page 6A. Please continue on with 6B.